Hello students, we studied about monosaccharides in our previous lecture. Today we will discuss about disaccharides. Disaccharides, these are the carbohydrates which on hydrolysis give two same or different monosaccharides unit. Or we can say that when two same or different monosaccharide units are joined together, then they form disaccharides. And the general formula of disaccharide is C12H22O11. And students, there are some common examples of disaccharides are sucrose, lactose and maltose, which are in our syllabus. Sucrose, lactose and maltose. Okay, now let's start with sucrose. Sucrose, it is commonly called as cane sugar or table sugar. It is the most common disaccharide and it is widely distributed in plants, particularly in cane sugar or sugar beet. It is manufactured either from cane sugar or sugar beet. The sugar obtained from sugar beet is called as beet sugar. Okay, and it is colorless, sweet and crystalline substance. It is colorless, crystalline and sweet substance, and it is soluble in water. It is highly soluble in water. And it is a dextrorotatory sugar. Dextrorotatory sugar, it means that it rotates the plane polarized light towards the right hand side. Okay, now let's discuss about its structure. Sucrose. Upon hydrolysis, sucrose give two monosaccharides with general formula C6H12O6, in which one is glucose and another one is fructose. C12H22O11. Sucrose, upon hydrolysis, in presence of acidic medium, it gives fructose and glucose. In this fructose, D-fructose and D-glucose. Okay, and students, D-fructose and D-glucose, both of them having the same molecular formula C6H12O6. Okay, they are having same molecular formula but they are having a different functional group. So they are functional isomers of each other. Fructose, it is an example of ketohexose. And glucose, it is an example of aldohexose. Ketohexose, it means it contains it means that it contains aldehyde group. Okay. In the structure of glucose, alpha D glucose and beta D glucose. Alpha D glucose and beta D fructose. These two units join to form sucrose. In this alpha represents that OH group on the first carbon atom is on right hand side, and beta, it means that the position of OH group is on the left hand side at the anomeric carbon. Okay, and in this plus symbol represents that it is a dextrorotatory form, and this minus symbol represents that it is a levorotatory form, and D represents here the configuration of OH group at the last chiral carbon atom. Okay, and if the position of OH is on the right hand side at the last chiral carbon atom, then it is called as D glucose. We studied about this in our previous lecture. Okay, alpha D glucose. We already studied this cyclic structure of alpha D glucose, which is a pyranose structure, 6-membered ring in which 5 carbon atoms are present. These point of intersections represents carbon. Alpha D, alpha it means on the first carbon atom OH is present on the right hand side, and if it is present on the right hand side, so it is represented at the downward side or the lower part. We already studied about its cyclic structure in our previous lecture on CH2, OH and H. And in beta D fructose, furanose structure, 5-membered ring in which 4 carbon atoms and 1 oxygen atom is there. This one is the second, third, fourth and fifth. Oxygen bond is present between the second and fifth carbon atom. And as it is beta form, so OH is present on the upper hand side. CH2, OH, OH, H, and on fifth carbon atom, CH2OH. It is always present at upper hand side, or we can say that on the left hand side. When these two units join, then the loss of water molecule take place, and these two units join with the help of oxygen. And this linkage is called as glycosidic linkage. When the two monosaccharide units are joined with the help of oxygen, then this linkage is called as glycosidic linkage. Okay? Sucrose. In case of sucrose, it is dextrorotatory before hydrolysis. But after hydrolysis, this dextrorotatory sugar is converted into the levorotatory. Dextrorotatory form is converted into the levorotatory sugar, and it is called as inversion of sugar. It is called as inversion of sugar. And students, as I told to you that when upon hydrolysis it gives alpha D glucose and beta D fructose. And fructose, it is levorotatory, and upon hydrolysis it gives alpha D glucose and beta D fructose, and the optical rotation of beta D fructose is higher than alpha D glucose, and alpha D glucose beta D fructose, it is levorotatory. So the dextrorotatory form is converted into the levorotatory form, and it is called as an inversion of sugar. The conversion of dextrorotatory into the levorotatory form is called as inversion of sugar upon hydrolysis. And one more definition is the invert sugar. Invert sugar, it is an equimolar mixture of alpha D glucose and beta D fructose. Okay, the equimolar mixture of alpha D glucose and beta D fructose is called as invert sugar. Inversion of sugar, invert sugar, and glycosidic linkage. These three definitions are very important from the board point of view. And one more question which is very important is that what are the hydrolysis products of sucrose? Okay, I hope it is clear to all of you. Thank you students, and have a nice day.